First things first, we can start with our poll question here, and I guess you all can see the responses as well as I can. It seems like things went fairly well. I assume Gucci Gang is good. And yeah, I mean, the sort of comment about for loops needing more training, well, lucky you, you'll have an opportunity to practice more with for loops in other parts of the course. So it's not only last week that we'll be dealing with for loops, but we'll encounter for loops in several of the lessons and exercises that are still to come. So that's good in that respect. The concern here about the exercises being maybe a little bit more like what we do in class together and that they're a bit harder than what we do in class, that is true, and that is also part of the reason why we have these two exercise help sessions, because it's sort of intentional. Like, we want to push you a little bit beyond what we encounter in class. We want to basically apply the same ideas you would use normally during our lectures, but apply them in a way that's maybe a bit closer to how you would actually use things, like when you're working on master's thesis, or after you leave the university and you're working, if you're using Python. These are meant to be a little bit more like what you would actually do in day-to-day use of Python. So yeah, the latest comment here about things becoming harder than they were earlier, that trend kind of continues at least through week 6 of the course. So I would just say, the best advice I could give you would be to be active on Slack. If you have questions, please feel free to ask them there, and also feel free, if you see someone asking a question you know the answer to, you can feel free to answer. And other than that, take advantage of the help sessions. I know it's a little bit inconvenient that they're on Thursday and Friday, because maybe you haven't gotten into looking at the exercise in detail yet, but do try to attend those help sessions, because even if you don't ask one of the course assistants for help, there'll be other students there working on the same thing you're doing. So it's kind of nice just to be able to kind of ask your neighbor, like, hey, what did you do for this problem? I don't understand why my code doesn't work, or whatever. I think that'll be an efficient way to be able to make progress, because the exercises build each week on things we've already learned. So in a sense, they get a little bit more challenging as we go forward. At the same time, I think you get to do cooler stuff. So that's a benefit in a sense. Like, you get to kind of each week do something that's more like what you would actually want to do with your Python programming. Then I guess there's a question about what pair programming. Maybe there's still issues with some people's partners not working properly or sort of communicating very well. And if that's the case, again, please let us know, ideally in Slack. I know there's at least 2 or maybe 3 people who I'm still trying to pair you up. So for this coming week's exercise, hopefully we can reorganize the partners so that happens. But if you're in a situation where your partner's like not responding to your emails or other attempts to contact them, just let us know, and we can always reorganize the pairs a bit, because there are some people whose partners didn't really inform them that they wanted to work by themselves until it was quite late, for instance, in this week's exercise. So if you let us know in Slack, we can try to sort things out to make sure everybody's partner is active and able to help them if they're wanting to be paired up. Then there is a thing here about the last exercise and how. I assume, is that about this making the flag kind of exercise? I suppose that's what the case is, because often there's questions about that one. Let me see. I've got to launch my CSC Notebooks instance, and if you haven't done that, maybe you can do that now. I thought I had everything all set to go, but I didn't open up Jupyter Lab on the CSC Notebook. So I'm going to open this up now, and then I can give you a demonstration of how to do the flag exercise if you're interested. There's a few different approaches you could take. Unfortunately, Christoph couldn't join us this morning, because I was going to ask him to maybe show how he would approach the problem, but I can at least show you how I would approach it, and note that there's several different ways to get the kind of correct solution. Okay, so things are opening now. And I think what I'll do is I'll just make a new empty notebook here just in the base directory to show you how I would approach things. So as a reminder, your goal here was basically to produce a pattern that looks like this, so that when you type print flag, and flag would be a character string that contains all of these characters, it would print out this pattern to the screen. And you were meant to do that using a for loop. And in fact, you could also do this a few different ways. Like we're suggesting that you use nested for loops to do it. And that's because basically you can check then as you go along each character along the line. You can have one for loop that basically takes you across the line and one for loop that takes you from one line down to the next one. So if we start with a slightly simpler example of just making the star pattern, the first thing I would do is just look at it and say, okay, first off, how many stars do we have? And it looks like we have 7 stars going across, or 7 asterisks, if I'm not mistaken, going across, and then 3 rows of that pattern. So we need to make something that has 7 stars and 3 rows of those stars. So I'm just going to put a comment here, 7 stars, 3 rows. So our first thing is that we're going to have some text variable. And you don't necessarily need to initialize this, but it might be easier in a sense if you do just start out with an empty character string. So I just said text equals that, and then we need a for loop. And like I said, what we'll do is we'll go across the length of the line first, and then we'll go down a certain number of rows. So we could say, for instance, for I in range, and we know that we need to go 7 characters across. So in range 7. That's going to allow us to basically add a star for each one of the stars that should be in our pattern in a given line. Then we can also, actually, why don't we do it this way? Let's do the star thing as for j in range, because I think what we actually want to do for our other for loop is we could say for I in range 3. And so let's add a couple comments here. So this one will handle the lines, the outer loop. You can do it either way, but thinking about it, I usually like to kind of have the line be the sort of outer loop, and then here is the line that would, or the sort of for loop that's going to handle adding a star to each position. So right now, if we were just to go through what's going to happen in these 2 for loops, this loop is going to start on the first line, and then it's going to go to hit the second loop and go 7 times through the inner loop, which would basically be like, if we're just adding a character to our character string, it could be 1, 2, 3, 4, 5, 6, 7 stars. Then something's going to happen, and we're going to finish this loop of adding the stars and then go to the next line. So there's a couple things that you maybe, I don't know if it was mentioned in the hints for the description of the exercise or not. Maybe we don't have something in here that's a kind of tip for how to break a line. But that's something that we will need to do, because what we want to do is print out this one character string to get this whole star pattern, not just like make 7 stars and print that, and then make 7 stars and print that, and make 7 stars and print that. So in this case, the first thing we can do is basically say text equals text plus star. So that's going to take whatever we have in our text string already, which starts out as empty, and add a star to it. This is going to happen 7 times inside this loop on the first line of creating the pattern. That's great. We've added 7 stars. How do we break the line? Well, that is what we're going to do. After we add 7 stars each time, we can then say text equals text plus, and let's do it like that. So this is a sort of special character or special thing in a character string that's a new line indicator or new line character that basically will break a line of text. So now we would have 7 stars plus something that says that's the end of the line, jump to the start of the next. If we run things like this right now, what would happen is we would go through 3 times making our 7 stars and adding a new line character to the end of it. If you run it, we're not going to see any output at this point because all we've done is filled in our character string. But if we print out what text is after running that, we get the pattern of the 7 stars. Maybe I will make this a little bit bigger. If I can, come on. There we go. Maybe 1 click down from there. Okay, so what we've done here with this basic structure is we have a loop that handles our 3 lines, we have a loop that handles our 7 stars, and each time after we finish adding stars, we have this one thing that happens in this first loop, and that is to add the new line character to the end of the text string. That's then going to be fine for us to be able to print out text and get our 21 stars broken onto 3 lines like you see here. You with me so far? Yeah, any questions at this stage? I know we didn't tell you about the new line character thing, so that was a little bit of why this is an optional exercise, because you would need to figure out how to do that. So this is our template, and we can use basically the same kind of template to do the flag pattern that we have here. Let's go back and just take a quick look and see what's different for our flag pattern. So when I look at the flag pattern, what I see first off is that we have our 7 stars like we had before, but then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I don't know, something, was it 11 or 12 dashes? 6, 7, 8, 9, 10, 11, 12 dashes it looks like. So 7 stars and 12 dashes on the first 3 lines, and then after that we have all dashes. It's the same number of characters on each line, so that if we said 7 plus 12, we're going to end up with our 19 characters. And so that's how long we expect each line to be, is 19 characters. But the first 3 lines are going to be different from the others. So that's what we have to do now with making the flag, is to sort of modify things a little bit, because now we need to have a condition in here that basically says, okay, if we're in the first 7 characters and we're in the first 3 lines, make a star, otherwise make a dash. So let's do that then. And maybe what I'll do is I'll copy this and we'll paste it in here as our sort of goal of what things should look like. Let's make our flag nice and straight like that. Okay, so this is the goal, to make this flag pattern like this. And I'm going to start by copying what we already had before. So we can take what we started with for making our stars pattern alone from above. Instead of calling it text, let's call this flag. And let's say flag here and flag here. Oops, flag. And 2 more. So things kind of work the same that they did before, except now we have 5 lines instead of 3. And now instead of having 7 characters, we have 19, because we have 7 plus 12 characters here. In addition, we don't just want to add stars for the whole pattern. So we're going to need to have a conditional statement in here. Our conditional statement in this case is going to be basically to say, if j, which is the variable we're using to iterate along our line, if j is less than 7, so that's going to give us our first 7 characters, because we're going to start with the range function at 0. So we'll have 0, 1, 2, 3, 4, 5, 6, 7. Well, that would be 8 thing. So 6, number 6 will give us our 7 characters. If our value for j is less than 7, then what we want to do is to add a star to our flag pattern. But that's not our only condition, right? Because we only want to do this on the first 3 lines. So if j is less than 7 and we're in the first 3 lines, which means that I is less than 3, oops, less than, not greater than, then we want to add a star. So that should allow us to basically kind of isolate this part of the flag up here in the top left corner. So if we are in the first 7 characters on a given line, and if we're within the first 3 lines of our pattern, put a star. That seems to be logical enough. So we just say, okay, if we meet these 2 conditions, let's add a comment here. So if we're on lines 1 to 3 and characters 1 to 7, put a star. If we're not, we need an else condition here. And our else condition can be pretty easy in this case, which is basically just to say that our flag equals flag plus a dash. So if we're not in this little corner of the flag, put a dash. That's our basic rule here. We don't actually need to worry about handling anything else because we have 2 conditions here that are going to allow us to figure out, are we in the top left corner of the flag? If we're not, it's all dashes everywhere else. So it doesn't matter. We'll just say, if you don't meet these 2 conditions, put a dash. And so this should essentially fill in our flag pattern already like this, because the same logic applies that when you reach the end of a line, you still have to add this new line character there. We had to do that before. But effectively, we have handled everything at this stage with our 2 for loops. So we have 1 loop handling the lines, 1 loop handling which character position you're in on the line. We have our condition to check and see, are we in the top left corner where we should be adding stars? And if we're not, then we're just going to add a dash. And as it goes right now, if we run this and then we print out our flag, if I've not screwed this up, we should get our flag pattern. So obviously this is a little bit more complicated example in terms of how things work for the exercise. It's kind of fun in a sense because it does require you to think about how do you break the problem down. But I think the important thing here in terms of looking at the problem is to recognize that you have a certain amount of similarity, that you have the same number of characters on each line, you have a certain number of lines that's known, and the only thing you really have to handle here is just identifying whether you're in the top left corner to be able to put a star there instead of a dash or a hyphen. So do you have any questions about making this flag pattern at this point? I mentioned there's a couple different ways you could do it. You could handle the first 3 lines separately and then have a condition that just checks to see for those first 3 lines, are you in the first 7 characters? This, I think, is probably, it might not be the shortest way to do this, but it's a pretty short way to do it. I mean, if you wanted fewer lines of code, you probably could just copy paste the flag and have 5 statements where you just add the whole line at a time, but that's not really the point of the exercise. We ask you to use nested for loops, so the expectation is that you have 1 loop for the lines and 1 loop for the character of each line. But yeah, any questions about that? I think if you haven't noticed on the course webpage, maybe I'll just show you this. If you haven't seen, down on the bottom left, there's this little read the docs thing. Our course webpage is hosted on a website called Read the Docs that's designed to host documentation for programming projects. And if you see this V latest, that's a version. And basically, when you go there, the default is that you look at the latest version of the web page. But if you go, you can actually go back, I think, even to like our 2017 version of the web page when things looked a little bit more old-fashioned. We've been having this this lesson as like an optional thing for quite a while in the exercises, this little flag. So if you're curious, you can go back and you could find some of the earlier lesson videos and see how other teachers in the course had approached this, because I think in the past we usually would have two teachers demonstrate how we solve this problem. So you could find the lesson videos if you're curious to see other solutions, just so you know. But yeah, we're going to stick to the latest version of the page for today's lesson. And speaking of today's lesson, let me just take one last look here at the Pressimo poll. Everything looks like that's all good. We've handled all that stuff. I wanted to maybe bring a couple things to your attention. So I just made some, like we had a discussion with the course assistants at the end of last week, and they mentioned a few things that might be good to remind you all about. So first off, just in terms of finding solutions to some of the problems you might encounter, it's a perfectly good approach to take some of the error messages you have and copy paste them into Google or into whatever your favorite search engine is. And this, I mean, honestly, this is how a lot of us work when we're coding things up. It's like if I get an error message I don't recognize, I'll just copy paste it into a search engine and go and look and see what people, what is the issue that's causing this according to other people who've encountered the same message. Python is used by a huge number of people, and as a result, you can typically find pretty useful responses for why you're encountering certain issues. And this applies both to the code itself and to any kind of weirdness you might have with Git or GitHub or Jupyter Lab. Like that might be a good first step when you're diagnosing or trying to figure out if something's wrong and you don't know why. It's just to copy paste the error message into a search engine. In addition, I'd like to encourage you all to ask questions in the public channels in Slack. So rather than sending us like DMs, it would be great to have questions, as long as they're not like very specific to or would require you to like sort of disclose the entire answer to one of the problems in the exercise. It's great to ask them in the public channel, because then everybody can see your responses and everyone can see our responses to your questions. And also other students in the course can and we encourage you to help out and answer some of the questions, because every year it seems like there's a handful of people who get become active on Slack and are happy to answer questions. You'll sometimes get a faster response to your questions that way, because to be totally honest, I mean, we don't sit there watching Slack all the time, although I've heard Justus is quite responsive. We've also told him that he should feel that he doesn't need to sort of sit there and immediately respond to everything that gets posted in Slack. So yeah, feel free to ask questions there. If you have something specific to your situation or a question about your partner or whatever, something you don't feel like is a public discussion issue, you can also send private messages in Slack, or you can send email if you need to. That's totally fine. But for questions about the exercises and about the lessons, it's great if you ask them in a public channel in Slack, and ideally like whatever the channel is for that week in the course. That would be a good place to ask. Another thing is that we never went through the good coding practice back in lesson 2. And this is sort of an oversight on my part. I don't think we went through this, or maybe we looked at it very, very briefly. But both back in lesson 2, we had this good coding practice about describing your code that was talking about like making code comments. I think I did maybe at least show you the page here, but this is essentially just talking about like different styles of comments. So like line comments in Python, if you start a line with this number sign or pound sign or hashtag thing, whatever you want to call it, if you start a line with that character, Python will ignore everything else on that line, everything that comes after that character rather. So this is one way in which you can add some kind of description to the code that you've written, which is something we're going to be asking for you to do in this week's exercise and in exercises that go forward from here. I think we may have even asked already for lesson 3. But these comments are really useful just to kind of explain what your code is supposed to do, because if it doesn't work, it also helps us to be able to see what you've done. So, there's examples here on the course page showing how these kind of line comments can be used. It can be done such that they're on their own line by themselves, or you can add a comment after something like a print statement, and you could then see that is also a perfectly fine way to have comments. And you can also basically comment out code. If you're testing something and a line breaks things, you can just put a comment at the start of the line to basically skip over the line that seems to be causing problems while you try to diagnose what's wrong. In addition, you can do these things called block comments in Python that start either with a double quotation mark or it's a triple quotation mark. It could be either single quote or double quote for the character. But typically in Python, it's the double quote character that's used, although it works with both characters. But you start and end with triple quotes, and everything between them will be then ignored or treated as a comment. So nothing will get executed in this situation. Typically, this is done when you have some characters or some kind of comment that needs to span multiple lines. You can do it with the line comments, but depending on how long this block of comment is, it's easier to do it with the block comments. And again, it's like you start with triple quotation marks, and everything between the starting triple quotes and the ending triple quotes will be ignored. So stylistically, this allows you to kind of organize your comments and make them look a little bit nicer if you like to do that. So there was that from back in week 2 that I don't think we went through, and I think we totally skipped the good coding practice last week, maybe because we were running low on time. But this is about what's called the PEP 8 style guide for Python. So this is something that describes Python's recommendations for how to style your code to make it as readable as possible, both for yourself and for other people who might look at the code. And we've highlighted a handful of different things here from the PEP 8 guidelines about things like the maximum line length that's recommended to use, indentation, white space, and other things like that. So the recommendation for line length, for example, is 79 characters. It's sort of a general recommendation because on the web page, for example, we limit it to 88 characters just because sometimes the narrower you make the sort of line length limit, the more your code then kind of gets stretched on the page. And so it's a sort of loose guideline, but something like that is handy to make sure that your lines are not so long that it's difficult to read things way out at the end of the line. Of course, indentation we dealt with last week. The typical indentation being 4 spaces in Python, and there's some examples here about some situations where you might need to have lines that get wrapped and how to indent those, and things like hanging indentation as well. So there are some situations where visually this might look nicer than if we organize things another way. There's also some suggestions about white space, which is basically just spaces between characters. So there's examples here of doing things like assigning the value to the character I and how to do that. And then there's examples of what not to do. So typically you'd have one space between an equal sign or a plus or a minus, anything like that. Any comparison, you would usually have a space between the variable and the number or whatever it is you're comparing against. So there's some examples like that. Suggestion to have one statement per line. So if you're going to print hello and world as 2 separate things, it's good to put those each on separate lines rather than this, which is valid code. To have a semicolon there it will work, but it can be difficult to read. So it's not recommended to do things that way. And then finally, there's some things here about readability versus code length. So it's a style guide. It's not a sort of rule book, and you must follow it to exactly as described, but rather it just gives you good suggestions for how to make your code easy to read. So I wanted to remind you about those 2 good coding practices since we overlooked them in the last class. And yeah, couple last things. One about the help sessions. So the course assistants just wanted us to remind you that you do not need to go to the help session you have registered for. You can go to whichever one is more convenient for you any given week. So just turn up there. It doesn't matter if you're registered for that help session or not. If you need help and you're available at that time, just go. So again, I think it's on Thursdays and Fridays. I don't remember exactly what the time is. Maybe it's from noon to 4 on Thursday and 10 to 2 on Friday or something like that. But you can check the course page for the info about when and where the course assistants will be able to help you. You can also go to both or neither of the help sessions. If you don't need the help, then you don't have to go. And if you really need extra help that week, then go to both if you've got the time. But please feel free just to attend whichever one's more convenient for you. Okay, and finally, the last thing I wanted to show you here is about the way in which we do grading in the course. So you've had some exercises that have been already graded earlier on, but for this, like basically starting from week 2 onward, we use this grading bot thing that we have put together over the years that will automatically grade certain parts of the exercise. So this is an example of my exercise number 2, for which I did not do anything but run the grading bot on it. You'll see if the grader bot has been run on one of your exercises. You usually get a commit that looks like this. It says GitHub Actions bot, grader bot added points to exercise whatever, exercise 2 in my case. And then if you look in your README file in the exercise, down at the bottom, you'll see that there has been some text added here. So the grader bot will add text to your README file that gives a summary of the points that have been granted or sort of given to you on the basis of the parts of the exercise that can be automatically graded. And that's not going to be 10 out of 10 points in any of the exercises, because we have things like where we ask you to sort of type in something about what your experience was with dealing with for loops or whatever. We can't automatically grade that, so it can only assign partial points. What you'll see though is that after the grader bot has run, you'll see that the grader is listed as grader bot and that this is awaiting review by a course assistant. So don't worry if you have, like 4 out of 10 points on the exercise and you're like, no, I'm pretty sure I did everything right. Don't worry about that, because basically it's just one of the course assistants will look your exercise over and then adjust the points there. Sometimes the grader bot doesn't work. Sometimes the tests that it uses to determine whether you did the right thing on one of the problems fail for reasons that aren't necessarily your fault, but more just about how we've designed the tests. So you can think about if you see any of your exercises with this grader bot as the grader, that's a preliminary grade, and it's going to most likely be adjusted by a course assistant, and typically you're going to have extra points added after that. So just to be aware that this is not the final grade for your exercise. It's just a preliminary grade. It makes things faster for the course assistants that we do it this way to kind of automatically grade the parts we can, and then they go back and just have to look over any questions where there's not a possibility to automatically grade, or if you've lost some points on one of the problems from, like let's say here in problem 2, that you could have gotten 4 out of 5 points from the automatic grading. If you have anything less than 4, then typically the course assistant will also check to make sure that the reason you lost points is because you did something wrong, not because the grader bot failed. So in those cases, you should be feeling, I hope, comfortable that we will still check things over by hand to some degree. If you have any questions about your points on any of the exercises after they've been graded and you see that the grader is one of the course assistants, then you can always feel free to ask the course assistant why you lost points on a certain problem or something like that. Okay, we had a lot of before we get started with the actual lesson stuff today. So are there any questions before we do that? because I've been talking for like more than half an hour and we haven't even gotten into our lesson for today. All right, let's do that then. So we are here in week number 4 of the course, halfway through. And our lesson this week is about functions. So that's essentially, we're going to focus on more or less a single topic. We'll have a little bit of variation, I suppose, in terms of how we deal with our functions, but that's our topic for today. Functions, and then we'll talk about modules, which are basically just ways in which groups of functions can be stored in a Python file and used by us in our programs. So we're going to talk about what a function is, how they are useful, and why we want to use them. We'll also teach you how to create your own functions and also how to save functions into something called a script file, which we'll get to in the second part of the lesson for today. So that's where we're headed. And so if you haven't already, it would now be a good time to make sure that you're signed into your CSC Notebooks environment. And we need to go, for example, here. I need to go to the My Work folder and then to Notebooks, and I need to pull the latest changes to the notebook. So I'm here in My Work /Notebooks, and then I'm going to go over to the Git Git plugin thing, and I'm going to click the button here to pull down the latest changes because I don't yet have my lesson 4 notebooks. So you should be able to do that. You should just go, and you'll notice after maybe a few seconds that this pull icon should get a little orange circle next to it. You can click that, and once you've done that, what you should see is that you'll now have this L4 directory that appears with your latest changes. So again, just as a reminder, it's in My Work, Notebooks in the file browser, and then you can go to the Git tool and just click the icon to pull the latest changes. Was everyone able to do that? I suppose that's good to know. If you're having problems, maybe raise your hand or somehow let me know. Okay. All right. So within the L4 folder, so if you go back to the file browser inside L4, we're going to start in the functions notebook. So you can just double click to open that one up. I'm going to hide the file browser at this point just so we can see, and let's get rolling. So there's a little bit of a description here at the start of the lesson about what a function is, and essentially you can think about it as like a little block of code that can make your programs a little bit easier to use, more effective, easier to read, and simpler to manage. The idea with a function is that any time you've got to do something several times within one of your programs, it's not a bad idea to create a function to do it, because rather than copying and pasting the code several times to do something, if you create a function, you can use the function anytime to basically be able to do that same operation. And this comes from the idea that it's really not a good idea when you're programming to repeat yourself. And by repeating yourself, I mean basically copying and pasting code in to do something more than once. In fact, if you use some of these developer environments where you're editing code in a text editor, they will actually flag places where you've repeated code and suggest that you find a way to not repeat what you've typed in. Because anytime you've copied and pasted something, if you want to make a change, you have to then go to every place you've copied and pasted and make the same change. Whereas if you use something like a function, you just change the function in one place, and everywhere that you then use it will also be changed. So let's take a look here at what our function looks like and what is actually the way in which we can define a function. And we can start by creating a function here to convert temperatures from Celsius to Fahrenheit. So we're kind of calling back to our first week in the course where we need to do this conversion from temperature data in one system to another. The way that you create a function is first with a keyword called def, D-E-F, is used to indicate you're defining a function. And then we're going to give the name of the function, in this case is Celsius to far, or what's sort of shortened from Fahrenheit. Then you have some parentheses, and inside the parentheses, you can give any values that we'll call parameters that are things that you need to use inside the function. And in this case, we're just going to pass in or use a variable called temp. That would be the temperature we want to convert. And then just like a for loop or just like a sort of conditional statement, we end the line with a colon character. So this is basically, we're going to create a new function called Celsius_def, and we've now indicated that we want to create that function with this def statement. Then we have to actually define what the function's going to do. And for every function, essentially, you give a value that should be returned when the user uses that function. So, for example, if you were to have something like the square root, you would return the square root of some number when you use the square root function. In our case, we're going to return our converted temperature. And we're going to return that using a statement called return. So this is essentially when you use the function, the value that's going to come out. And we'll see how that works in just a second. But what we want to do in our return function or our return statement here is that we're going to take 9 divided by 5. So this is our conversion of temperature from Celsius to Fahrenheit. So we'd have 9 divided by 5 times our temperature that's passed in, the variable named temp. And then we're going to add 32. So that'll allow us to convert from Celsius to Fahrenheit. So again, this is just our conversion equation, and that's what's going to get given back as a value when we use the function. So if I run this, nothing happens. Well, at least nothing happens in terms of any output to the screen. But what this does is it's now created a function that is in memory in the computer inside of our Jupyter environment that we can now use to convert temperatures. So we've defined it. We have our sort of equation here that will convert our temperatures. And then now we can see what happens when we try to use that. And so that's down here in the section called calling functions. So if you just scroll down a little bit, we can now maybe use a test case and figure out, okay, does our function actually work properly? And we can test this out by using the freezing point of water. So if we create a variable here called freezing point, not pint, but point, not a very good typing day so far. So freezing point, we're just going to say is equal to the name of our function, Celsius, to var. Wow, this is, there we go. And we're converting from Celsius to Fahrenheit, and as you know, the freezing point of water in Celsius is 0 degrees. So we'll put in the value of 0 here for that conversion. Now if we run this, what will have happened is we'll have converted the temperature from Celsius to Fahrenheit of 0, and that variable, or that value, has been stored in the variable called freezing point. Now if we want to take a look at that, we need to use a print statement, and let's do it with an F string. So we could say the freezing point of water in Fahrenheit, and you can just put F if you want to keep it short, is, and then we would have here inside the curly braces, freezing underscore point. So this is our variable value that's been converted from Celsius to Fahrenheit, and then we just have some text here saying the freezing point of water in Fahrenheit is freezing point inside the curly braces. And if we run this, we see the freezing point of water in Fahrenheit is 32. Whether or not you know that, that is the correct conversion. You can see up here that we should get a temperature of 32 degrees when we do this conversion, and sure enough we did. So it looks like our function is working. So what's happened here is basically our temp that was put into our function of 0. So if we go back to our function definition here, we had defined it with this parameter called temp. Basically, we have assigned the value of temp to be equal to 0, and then inside our function, we've done 9 over 5 times 0 is 0, plus 32, and we return that value to to the variable that's being assigned. So if we wanted to just take a quick look here, we could just add a cell. And if we did Celsius to far again, and let's just put in 0. If you just run this like this, what you'll see is the value that gets printed out below here is our return value. And if you put in some other temperature here, you can see that, you know, if we put in 10 degrees, we get 50 for the temperature that's returned. If we put in 20 degrees, we get 68. So this seems like our function's working. And obviously this is really nice because instead of copying and pasting the formula every time to convert things, we just change the number that's inside the function when we use it, and we get a different temperature coming out. So that's kind of the idea here. This is a very simple kind of example to convert temperature from Celsius to Fahrenheit, but you could imagine that, you know, functions can be a little bit more complicated than this. And rather than having to copy 5 or 10 lines of code every time you want to do something, if you make a function, then all you have to do is call a single thing like this, and you get a value printed back out to the screen. So, so that's handy. And we could, for instance, look at another example here. We can do like what we did here to assign a value. I'll just move this up. We can assign a value to a variable and then print things out with the variable name, or we could do this differently, and we could just say, like, let's print out the temperature of the boiling of water in Fahrenheit, and we could say the boiling point of water in Fahrenheit is, and rather than putting a variable name inside the curly braces, we can just put in a call to our function. So we could say Celsius to far, and inside the parentheses here, we'll put in 100 degrees because that's our boiling point of water in Celsius. So this is a fine way to do it too. It looks more or less like what we did above, except for here we had put a variable value inside the curly braces, and here we're calling a function inside the curly braces. But it works the same way regardless. So sometimes this can be a handy way to do things. It sort of depends, again, a little bit on the readability of the code. This is pretty readable like this because we're just doing a simple conversion of a single value. But as you'll see, you can have more than one parameter in a function, and if you have a function with 10 different parameters in it, probably you want to not do things this way because it will make your line quite difficult to read. But if you run this, you'll see the boiling point of water in Fahrenheit is 212 degrees, which again is the expected value. So we can create functions, we can use them, this is cool. This can save us sort of space in writing our programs, but also make things reproducible and safer to use, because every time we want to convert from Celsius to Fahrenheit, we have one function that does it, and it means that we can feel confident that this is going to work reliably. Now let's make another one. So our next function is going to be to convert from kelvins to Celsius. So this is maybe not as common of a conversion, but we can do things more or less the same way that we did already, and that is that we can start by creating a new function in the cell here, and we could call our function definition. We'll start with a def statement, and we'll call our function kelvins to Celsius. So that'll be the name of the function we're going to use. Again, I'll just put the colon character here already just so I don't forget. And then we need to give the name of the parameter value that's going to be inside of this function call. And in this case, why don't we call it temp underscore kelvins? It does not need to be called temp kelvins. If we wanted to just have temp in here, that would actually be okay. It would not conflict with our other function. But for the moment, let's just call this temp kelvins, and we'll talk about this issue of naming parameters and things like that a little bit later in the lesson. So in this case, we're told here that the Celsius temperature is just the temperature in kelvins minus 273.15. So if we're going from kelvins to Celsius, then what we should be doing is just converting things that way. So if we had some temperature in kelvins and we subtract 273.15. That should give us a temperature in Celsius. So in our return statement in this case, we can just take our temp kelvins. Oops. Temp kelvins minus 273.15. So an even easier conversion function in this situation for our second case. So we've defined it, we've given a name, we have one parameter here. That parameter is used inside the function where we subtract 273.15, and then that's the value that gets returned, okay? So we run that one, and now we have this Kelvins to Celsius function available for our use. Let's put it to the test. So we can start by converting the temperature of absolute zero. So 0 Kelvin to Celsius. And we'll say absolute zero equals kelvins to Celsius. And inside of the parentheses, we'll put in a temperature of 0 kelvins. So that should give us the Celsius temperature of absolute zero. Again, if we run this cell like it is, we will calculate what that temperature is and store it in a variable called absolute zero, and then we can print this out to the screen with a nice F string saying absolute zero in Celsius is, and then curly braces and our converted value here, and we call that variable absolute zero. So hopefully, given that we know from our definition up here that the Celsius temperature is just the temperature in kelvins minus 273.15, we should know what to expect here. So we should get a temperature of minus 273.15 in Celsius. And let's see whether our function worked properly this time. So absolute zero in Celsius is minus 273.15. So yes, indeed, it does seem like this is working properly. So now it's your turn to check your understanding about how things are going with functions at this point. And to do this, we're going to use another temperature scale, one that you, I would guess, probably haven't used before, and that is measuring temperature in degrees Newton. This is a temperature scale that was created, I think, really before the kind of concept of temperature was formally defined. But it's one in which there are a few points that are sort of recorded as values like water freezing at a temperature of 0 degrees Newton and boiling at a temperature of 33 degrees Newton. And we're going to make some assumptions here and just assume that the increments between 0 and 33 are kind of equally spaced like they are for Celsius temperatures, which would allow us to come up with a way to convert from temperature in newtons from a temperature in Celsius. So if we have a temperature in Celsius and we multiply it by this, we get our temperature in degrees Newton. So your task here is to create a function called Celsius to Newton, and it has one parameter in it. That would be our temperature in Celsius that you pass into it, and it should return the value of a temperature in degrees Newton. And you can do that in the code cell that's here, and then once you're finished with that task, we can continue. We were tasked with making a Celsius to Newton function. So again, if we're creating a function, we start with our def statement and then the name of the function. And it's Celsius to Newton in this case. And inside here, we're going to give some temperature that's going to come in and value of Celsius. So let's just call it temp Celsius for the name of the parameter here. Lucky for us, the conversion factor is fairly straightforward, so we can simply, from our function, return a value called, or just return a value rather, that is the temp Celsius times 0.33. So that'll allow us to create the function. And if I run that cell, it's been created. Maybe it's good to add a cell underneath it so we can test things. And if we just take our new function, Celsius to Newton, and we give it some value, let's say of 0, our expectation is that water freezes at 0 degrees Celsius. It also freezes at 0 degrees Newton, so we should get a value of 0 when we run it like this. And yes, indeed, we do. So that passes the first test. If we had water boiling at a temperature of 100 degrees Celsius, and we know it boils at a temperature of 33 degrees Newton, we can run our function again with a value of 100, and we get 33 back. So everything seems to be working properly, and I hope your function worked similarly. So very good. All right, so then let's take one more example here. And that has to do with using functions within a function. So it's possible in defining a function to actually call and use other functions within it. And in our case here, we're going to create a new function called Kelvins to far. So we'll convert from Kelvins to Fahrenheit in our function. And we're going to take advantage of the fact that we already have a function to convert from Kelvins to Celsius, and we have a function to create from Celsius to Fahrenheit to allow us to, rather than coming up with some new conversion equation, to simply use the functions we already have. So in this case, our function is going to be Kelvins to far. So we'll start out our function definition like we always do with a def statement. Then we have our parentheses, and I just like to add the colon character at the end of the line already. The thing that's going to come in here is going to be a temp in Kelvins. So we might as well call it temp Kelvins as our parameter. Inside the function in this case, we're going to have a couple different steps. So first we can create a variable in here called temp Celsius. And this is where we're going to convert our temperature from Kelvins to Celsius using the function we already have for doing that. So we'll say temp Celsius equals Kelvins to Celsius. Oops. And the Kelvins to Celsius value we're going to convert is our temp Kelvins that's passed into the function. So when we use the function, we pass in some number. That number is going to go here and first get converted from temperature in Kelvins to temperature in degrees Celsius. Once we have our temperature converted from Kelvins to Celsius, we can then do another conversion where we convert from Celsius to Fahrenheit. So we can have a temp far as an example, where we take another function that we already have, which is Celsius to far. And we convert our temp Celsius value that we just calculated the line above. So Kelvins go first from Kelvins to Celsius. There's that value in the variable called temp Celsius, and then we convert from Celsius to Fahrenheit in the second line of this function. And finally then we can return the temp Fahrenheit value, or temp far value. So this is kind of nice because we're taking advantage of other functions we've already created to do some of these conversion steps for us. So what's a little bit different here, obviously, is that we're using functions inside of the definition of another function. And as long as Kelvins to Celsius and Celsius to far have been defined elsewhere in the code, this will work perfectly fine. If you just copied and pasted this one code cell into a new Jupyter notebook, of course this wouldn't work because these functions haven't been defined in that other notebook. So be aware that this does require that we have a function already available to us called Kelvins to Celsius or Celsius to far. But beyond that, we're then able to take advantage of those functions to convert things. The other thing I wanted to point out here is that we've been returning like some equation or calculated value in our earlier examples. Here we're now returning a variable value, But it's just going to return whatever the number or text or whatever it is that's stored inside this temp var variable. It won't know anything about what the variable name is or anything when you use the function. It just has the value that's been converted. So we have this. To convert from Kelvins to Fahrenheit, it's now been defined because I ran the cell. So let's take a look and see what happens when we use it. So we could, again, for example, take a look and use an absolute 0 in Fahrenheit or far variable. And this is going to be now Kelvins to far of the value of 0 kelvins. So we're going to store that in a variable called absolute 0 in far or absolute 0 far, whatever you want to call it. And that's going to be our temperature of 0 kelvins converted to Fahrenheit. Run that cell and we've done that part. Now we need to print it out to the screen. Let's do that with an F string like we always do and say absolute 0 in Fahrenheit is curly braces absolute 0 in far. So that's the value we just calculated. I don't know what this value is expected to be, but we have our two functions we've already used and we know that they're working properly, so I think we can safely assume what we get here is going to be correct. Just to give a rough estimate, I'm thinking it's going to be something like minus 400 something, because we already know absolute 0 in Celsius was minus 273, and typically the values in Fahrenheit are larger, whether positive or negative, than the values in Celsius. So we'd expect something like minus, I don't know, 400 something. Let's run it and see what happens here. So we see absolute 0 in Fahrenheit is minus 459.6699999, blah, blah, blah. This looks roughly like what we would expect in this case. We would probably want to test some known values here. So if we know that, for example, 273.15 is the temperature in kelvins of 0 degrees Celsius, which I think we can safely say that we know. And we know that 32 degrees in Fahrenheit is the sort of temperature at which water freezes. If we run our code again, okay, now this is not absolute 0 in Fahrenheit, but whatever. Let's not change it just because this will be simple just to demonstrate this way. But if we put in 273.15 kelvins, we expect to get a value of 32 out. So if we run this again and run the two cells, okay, there's our absolute 0 in Fahrenheit. Okay, it's not 32, but you get the idea that our function seems to be working properly. Let's maybe put this back to 0 just for the sake of demonstrating things. And just as a reminder, when we're using the F strings and we have some little thing inside the curly braces here, if you want to reduce the number of decimal values that are shown or number of values shown after the decimal place, we could say, for example, colon 0.3f, which would give us 3 decimals, or even colon 0.2f, which would give us 2 decimal points or 2 values after the decimal point, and represent this as a floating point number. And why did it give us zeros after that? That seems odd. Maybe there's some kind of weirdness with the rounding. I don't know why it's doing this. I would have expected only to have I don't know why this is not working. That's odd. Well, I don't know. I've been teaching this course for quite a few years, and I thought I knew how F strings worked in the formatting, but I seem to, for some reason, have encountered a case I don't understand. Yeah. Ah, yes, thank you. They're missing the decimal point there. There we go. Okay. Thank you for being attentive and doing things that I should be doing, like thinking. So, yeah, in this case, what we have, or what we were missing, was without the decimal point there, then we're essentially asking for a different kind of representation of the number. So :point to f will round things to two decimal places as expected. So you can make your output look a little bit cleaner that way. Because what was funny here is, like, depending on the value we're converting, we get different numbers of decimal places, and often if you have printed output, it's nice to have it look kind of consistent. So with that, why don't we take a break here? If we can keep it to maybe 10 minutes, that would be good. And then we'll come back. We'll talk a little bit about functions and sort of namespace stuff, and then we'll go into dealing with script files. So let's continue in 10 minutes.